Hello and welcome you all to the fresh episode of Defense Fallout. So I've heard a lot of technical terms when you come across content related to air-to-air missiles, or at least in the defense sector when randomly someone refers to these topics. Now we commonly use these terms known as active radar homing missiles or semi-active radar homing missiles, infrared missiles, imaging infrared, etc. Now, in these kind of terms, when you come across, you might not properly know what does it mean. So let us discuss all about these things in today's video. So let us first understand that an air-to-air missile is generally used to target enemy aircrafts. Let it be their helicopters or support aircraft like their air-to-air refuelers, transporters, or the AWACS, or let it be their fighter jets. So in order to direct these missiles towards the target, we need to use a proper guidance mechanism, which sounds very simple but yet a very complex task. So as we know, the air battles are basically divided into two types. One is the within visual range combat or the WVR, and the target is visible to eyes, or at least even if it is not visible, the targets are closer than 18.5 kilometers from each other. So this is the general specification of the within visual range combat. Now anything beyond this is called the BVR combat or the beyond visual range. So depending on the scenario, a wide spectrum of missiles are used, and missiles are specifically designed for specific combats. Now a BVR missile can't function effectively in a dogfight. A dogfight is nothing but a combat which you get into in a within visual range. Now in a dogfight, a missile can't, if you use a BVR missile in this scenario, it might not work so effectively. Now, when it comes to these BVR combats, you can't use a dogfight missile because technically it can't achieve the range which it requires for a BVR combat. Now, this is what makes us to design completely different missiles. So when you have completely different missiles, you have to have different guidance mechanisms too, and which keep these missiles very different. Now, keeping in mind of these missiles, the energy which a missile gains is very different in each of the scenario, and the rocket boosters which are used, that can be a single pulse, dual pulse, or ramjet. We will discuss about this in the next video. What are these three? The single pulse, dual pulse, ramjet, and even the scramjet. Now, also the amount of electrical power available on the missile to back the guidance system, and the missile's maneuverability or the maneuvering capabilities or the moving capability determines what kind of guidance mechanism you have to use. Now let's discuss each of the guidance mechanism one by one. Now when it comes to the active or guidance systems, in that you have two types. One is the semi-active systems and the active radar homing. Now when it comes to the semi-active radar homing missiles, where the missile is usually used in a BVR combat. So these missiles are generally used in the BVR combat. The range is not that great. Okay, 30, 50 or max of 70 kilometers is the maximum range which they can achieve. Now in this scenario, which are generally used in the BVR combat, the launch platform, let it be a fighter aircraft, provides the target and tracking information to the missile by the use of a receiver which is fitted on the missile. Now the missile then follows the tracking information and homes onto the target. Homing is nothing but locking itself on the target, but this requires the launch platform to turn the radar on the or point the radar in the direction of the target until the missile hits the target. But an advantage with semi-active homing is that it is resistant to target's radar jamming capabilities. That is, in technical term, what we call it as noise jamming, where false radar signals are sent to confuse these radar homing missiles. So because the semi-active radar homing missiles get information from the fighter aircraft, so they become resistant to these noise jamming capabilities. Now, there aren't many semi-active missiles in service because of the limited range which they offer, but a few surface-to-air missile systems can be a great example for these semi-active missiles. Now, when coming to the active radar homing missiles, they have their own radar, hence having their own battery to power it, and also they obviously become heavier because you have your own radar, you have your own batteries, and sometimes you need cooling for these radars. So it makes the missile a bit heavy, and load limitations come onto the aircraft. But keeping this aside, when we speak about how it works after the missile is launched, it uses its own radar to find the target, and it homes itself onto the target and will be prone to electronic countermeasure systems, which I already spoke, that is noise jamming. So these are prone to these electronic countermeasure systems. The advantage is that the launch platform need not have to point its radar onto the target, or at least turn the radar on until it hits the target. So this is the advantage which it gets. And sometimes we see launch platforms guide the missile at least till the mid course, from where the missile radar, which is fitted on the missile, takes over. Now both these missiles, that is the semi-active and the active radar homing, are prone to deviation because of chaffs. Now these chaffs or shafts, which is nothing but a countermeasure system, which consists of a thin aluminium, glass fiber or plastic pieces. Now which show up as targets on the radar and confuse the missile and trigger the missile fuse. Now this is nothing but the waste of missile. The best example for active radar homing missiles are the AIM-120 AMRAAM, or the Meteor missiles, and the DRDO Astra. So these are common missiles. Now the disadvantages with these missiles is that they send out radar signals triggering the missile approach warning system, so which obviously alerts the target and increases the situational awareness of the enemy. Now you don't want that to happen in a combat. Now when it comes to these infrared missiles, they come into the category of passive guidance systems. Now the infrared missile systems, obviously because they are passive, they don't have their own guidance system. Now that doesn't mean that they don't use any guidance system at all. It just means that they don't actively send radar signals or any signals for that matter onto the target, but they listen to the infrared radiation of the target and follow the infrared radiation. As the fighter aircraft body is very hot because they travel at supersonic speeds, and also these jet engines emit a lot of exhaust gases, they use afterburners, because of which the whole environment is very hot, and these targets have high infrared signatures. Now these missiles are also called heat seeking missiles because of this reason, that they follow the heat coming out of the target. Now because these missiles don't send out any radar signals, the MOS, or the missile approach warning system on the target, is not triggered, and hence it is difficult to identify the launch, and pilots usually look back onto the enemy aircraft just to see whether there is any smoke, so that they can get into a defensive posture. Now usually pilots also anticipate a launch and take countermeasures. Here the role of flares come in when we speak about countermeasures, in which there is something similar to chaffs or shafts are used. Now flares are commonly composed of a pyrotechnic composition, that is nothing but, okay, let us keep it simple. Magnesium or any other hot burning metals are dispensed into the air with a burning temperature equal to or hotter than the engine exhaust itself, and hence it confuses the missile. So to overcome this thing, we use nothing but the imaging infrared systems, where the missile has a camera in it which can look at the target and doesn't get confused with the countermeasure systems. Now that's the reason we call it imaging infrared, because it has a camera which can see the target. Now the best example for imaging infrared missiles are the MBDA Mica. I mean the specific variant of MBDA Mica which uses this imaging infrared, and you also have an extended range version which uses again the active radar homing. Now also the AIM-9X Sidewinder is also a very famous missile using this imaging infrared. Now that's it for today. Thank you, Jai Hind, and Vande Mataram.